In this video, we'll be talking about regression and we'll also implement the gradient descent method to find the best fit line. So let's get started. We'll start with what regression is. Regression is considered as a technique used to define the relationship between a dependent and one or more independent variables. Let's understand more about regression through a graphical approach. Regression involves two variables on the x and the y axis, the independent on the x axis, the dependent being on the y axis. The main objective is to find a relationship between these two and then draw a line or a curve to define this relationship. We try to understand that as the independent variable moves, what impact it has on the dependent variables and how it changes. If both the variables move in the same direction, that is, let's say if both of them increases, it is said to be a positive relationship. And on the other hand, if both of them move in different directions, let's say if independent increases and dependent decreases, it is said to be a negative relationship. Let's understand the different objectives that regression fulfills. First is it estimates the nature of the relationship based on the obtained regression lines. Second, it defines the size of the relationship, that is the magnitude of change in dependent variables. Then the strength of the relationship and the statistical significance of the relationship. The other objective is to forecast unobserved values based on the current knowledge of the relationship. For example, forecasting the sales of the next quarter based on the values of the previous quarter and the current quarter. Let's talk about the different types of regression. There are different types such as the linear regression, logistics, polynomial, stepwise, ridge, lasso, elastic net. Now in this video we'll only talk about linear regression. So let's start with linear regression. There are two types of linear regression, the simple linear regression and multiple linear regression. Simple linear regression uses one dependent and one independent variables. Multiple linear regression uses one dependent and two or more than two independent variables. Now this changes the formula that they use to find the best fit line. So regression uses y equals to b0 plus b1 x1 plus e, where x1 is the only independent variables, and multiple linear regression uses this formula to bring in all the independent variables. Let's talk about the different variables used here. Now b0 here is the constant, which is the y-intercept of the line, and b1 is the slope of the line, and e is used to define the error in the estimated and the actual value. We'll talk more about all these in the coming slides. Okay, so let's begin with what simple linear regression is. Simple linear regression follows this formula as we've already seen. It has one dependent and one independent variable, and let's use these variables through a graph and understand what simple linear regression does. Okay, for implementing regression we need different observation points, or which are also known as data points. We need multiple such data points for our regression model. So let's say we have these many data points. Now we try to find a line that best fits these data points. Let's say this is the regression line that best fits this current data set. Now this here is the estimated value on the regression line, and the difference between the estimated and the actual value gives us the error in that particular data point. Now since the data points are all scattered on all over the graph, there are multiple such errors that can occur in the data points. Now our main objective in regression is to minimize this error as much as possible. Now let us understand more about simple linear regression through a real life example. Here we have employee data with the experience on the x-axis, and that is in years, and on the y-axis we have salary in dollars. Okay. Now we are also provided with a data set with data points scattered in this manner, and we've already known that the simple linear regression uses this formula. And in this particular case, the y denotes the salary and the x denotes the experience. Now when we write this formula again, we can say that salary equals to b0 plus b1 into experience. Let's talk about b0 and b1 a little more. Okay, now b0 is the y-intercept as we've already talked about. Now let's say this is the particular regression line that best fits the data points. So drawing a y-intercept, we need to trace back to the point where the regression line crosses with the y-axis. So let's say this is a particular point, and here the value is $50,000. What this means is a person with 0 years of experience, or a fresher, will be paid $50,000 in the company for working. Now, the other thing is what B1 is. B1 is the slope of the line. Slope of the line is calculated by calculating the change in y and the change in x. Okay. Now to understand more about the slope, let's take an example. Let's say a person has gained 2 years of experience in the company. Now, by the slope of the line, we can say that his salary should increase. Now, to estimate the exact salary increase, we have to project the points on the x-axis on the y-axis. So we'll project it in this manner. Now we have projected it on the y-axis, and we can find the difference between the two lines, and let's say it is something $30,000. So this suggests that a person that has gained 2 years of experience will have a $30,000 increase in his salary. Okay, so that is what a slope does. A slope calculates, or it estimates the steepness of how the values will increase. The steeper the line, the more the salary as the experience increases. Okay. Now there are different challenges that one faces while implementing regression. So first we'll start with how to draw a line through observation points. This is one of the challenges that one faces, that since there are different data points and they are scattered all over the space, it becomes difficult to draw a line that satisfies all the points. And the second thing is there can be numerous lines drawn through the data points, but to find the best fitting one is always challenging. Okay, so all these challenges are met in the are dealt with in the next section.
Hello, I'm Amar Sharma and I'm going to discuss the practical implementation of linear regression using gradient descent approach. So, first we will recap what linear regression is, and then we will define the loss function, and then we will take a look how the gradient descent algorithm works, and finally we will implement it on a data set and make predictions. So let's get started. So the linear regression. So linear regression is a statistic based approach to model a linear relationship between a dependent variable and an independent variable, where if independent variable is one, then it is called as simple linear regression. If it is more than one, then it is called as multiple linear regression. So let x be the independent variable and y be the dependent variable. uh, we will define a linear relationship between these two variables as y is equal to mx plus c. Here m is the slope and c is the intercept. So our goal is to determine the value of m and c such that we get the minimum error or the best fit line. So, and to calculate the error, we need to define one cost function. It is also known as a loss function. So we are going to use the mean square error function to calculate the loss. And here yi is the actual values and y hat are the predicted values. So now let's move forward and talk about the gradient descent algorithm. So gradient descent is an iterative optimization algorithm to find the minimum of a function. So let's move forward and see how does it work. So in step one, we are going to define a cost function. So as we have previously discussed, as we are going to use the MSE, which is mean square error, as a loss function. So in step two, we'll derivate this loss function with respect to the each of the parameters to the model. So we have two parameters. The one is m, which is the slope, and the other is c, which is intercept. So first we are going to partially derivate the loss function with respect to m, because we want to see how much the loss varies with respect to this m. So here is the equation which shows the partial derivative of a loss function with respect to m. In a similar way, we are going to partially derivate the loss function with respect to c, which is our intercept. So this would be our equation, and the final step would be to update the weights. So sorry. So we are going to use these two equations to update the weights. So the first will be m is equal to m minus lr into the gradient. So here lr is the loss function. Lr is the learning rate, which is nothing but a parameter to a gradient descent algorithm. So in such a way, we'll update the weights in a iterative manner. So we'll keep on updating the weights until we reach to the minimum of a loss function, or we get the best fit line. So this is all about the theoretical part. Now let's see the practical implementation of this. So we are going to implement this in a Jupyter notebook, and here you can see these are the libraries which are required to implement this linear regression using gradient descent approach. So let me import all the libraries first. So I have imported all the libraries, and now let me load the data set. So yep. Here is the data set. As you can see, the data set consists of the marks obtained by the 223 students in a 10th class and in the 12th class as well. So we are going to define a relationship between these two variables. So uh, as you can see, there are none values as well. We'll handle that later. So first I'm going to take a list of this marks in 10th and the marks in 12th in a separate list. So got the marks in 10th and their corresponding marks in the 12th class. So now the next we are going to handle the missing values. So we are simply ignoring the NaN which is not available values. So we are just discarding those values. So we have discarded the null value. The next task is to analyze the relationship in between these two variables, the 10th class score and the 12th class score. So the first approach we are going to uh, we are going to apply in order to find the nature of relationship is the scatter plot. So first we are going to plot the scatter plot between the scores of 12th class and the score of 10th class. So as you can see, there's a kind of positive linear relationship between these two variables, as the marks in 10th is high and the corresponding marks in the 12th is high as well. So it's kind of linear relationship. And we are also going to check the correlation coefficient in between these two variables. So as you can see, the correlation coefficient is positive, which means there is a positive relationship between these two variables. So now our task is to find the best m and c, which is the parameters to the model, to get the minimum error. So first we are going to initialize the slope and intercept with the random values. So we have initialized this m and c with the random values. Now we need to define one function which takes x, which is our independent variable, as an input, and m and c, which are our parameters, and returns the predicted value. And the next task is to define a cost function. So this is the practical implementation of mean square error. So it is nothing but the square error between the predicted value and the actual values. Now, so now we are going to implement the gradient descent algorithm. So as you can see, these are the two equations that we have derived previously. We have just practically implemented this, and in each epoch, which is like in each iteration, we are updating these parameters m and c. And here is the learning rate is the parameter to this gradient descent algorithm. And in each iteration, we are printing the cost, slope, and the intercept. And we are also going to plot the scatter plot and the line between this 10th and 12th marks in each iteration. And we have also specified this timer in order to analyze properly what is going in each of the iteration. And at the end, this function returns m and c, which are nothing but the updated parameters. So let's move forward and run this all cells. And now the next step is to train. So we are going to call this gradient descent train function, and we are passing those randomly initialized parameters along with the learning rate, which is 0.001, and the number of iteration, which is number of epochs that we are going to use is 10. So let's run this and analyze what is going on. So as you can see, the line is pretty far away from the actual data initially, as we have initialized with the random numbers. Now, as you can see, in each iteration, our cost is getting low and low, and our slope and intercept is getting updated. And as you can see, in each of the iteration, we are approaching to the best fit line. So yeah, so we set the epoch which is equal to 10. So in the 10th epoch, we got almost the best fit line. So this is how gradient descent algorithm works. So now let's do some predictions. So let's suppose if the marks in 10th is 81.43, then how much like what will be the score in 12th? So we are going to predict that. So we are going to pass 81.43 and the new which is updated slope and intercept to the predict function, and we call that. So yeah, so when the marks in 10th is 81.43, then the predicted marks in 12th is 75.01. And the second prediction, let's see. So when the marks in 10th is 93.13, then the predicted marks in 12th is 85.61. So this is the whole thing, like how a linear regression can be implemented and how we can find the best fit line using gradient descent approach. So this is all. Thank you.